Alright, continuing on about inverses. The first type of problems we're going to do is look and show that f is strictly monotonic. Remember, that means that it's always increasing or always decreasing. And so we're going to show that it's monotonic on the given interval and therefore has an inverse on that interval. So the easiest way to do that is just go ahead and graph the picture. Now the absolute value of x actually makes a v, but we're only talking about from negative 2 to infinity. So if I plug in negative 2, I get 0. And if I plug in negative 1, I get 1. And if I plug in 0, I get 2. And so on and so forth. So it is always increasing on this particular interval. Therefore, it has an inverse. So we'll go ahead and write that out. F is increasing on 0 to infinity. Therefore, f is strictly monotonic and has an inverse. On the next picture, again, what we want to do is look from 0 to pi. And I've actually gone ahead and graphed the cotangent. The cotangent of x is right here. And so it's going from 0 to pi, and pi and 0 are not included. So you can see that it's always decreasing the whole time. So using the graph again, I can now say that it is f is decreasing by the graph on 0 to pi, and therefore f is strictly monotonic and has an inverse. In the next problem here, we're supposed to find the inverse of f over the given interval, and then we're going to use a graphing calculator to graph in the same window. You guys can do this if you choose. Really all you're going to see is that it is symmetric about the y equals x axis. So what I'm going to do is go ahead and write this as 2y equals 2 minus 3 over x squared. And then what I'm going to do is go ahead and, this isn't a point, this is an interval. So we're just supposed to show this over this one interval. It really doesn't matter. We're just going to still flip-flop the x and the y. So that way I can find its inverse. So I will subtract 2 from both sides. And then I will multiply both sides by y squared. Then I'll divide by x minus 2. And then I'll square root both sides. Now I'm only going to have the positive square root of that because I'm talking about the positive values of x. This next one, we're supposed to use a graphing calculator to graph the function. I will try to graph that very quickly here using this. I may end up having to do it in the next video. We'll see how quickly I can get this typed in. So I've got x, and then I have the square root of. I need to find my square root. 4x, or 4 minus x, to the second power. And I'll enter that, and we'll see if it will graph it. And I'm not, oh, there it is graphing now. Notice how this is not 1-to-1. It's not passing the horizontal line test. So we can say, determine whether it has an inverse. The answer is no inverse. And I'll finish this on the next. Alright, in these problems we're going to decide whether the function is 1 to 1, and we're going to find its inverse. So in this first one, I have just the graph of a horizontal line. We can now see that it doesn't pass the horizontal line test, so this is not 1 to 1. The second problem is a picture of any line, so it could be always increasing or always decreasing. So since it's monotonic, we can now say that it has an inverse. Its inverse could be found by flip-flopping the x and the y and then solving for the y. So I'm going to do that, flip-flop the x and the y, and then I will solve for y by subtracting b off both sides and then dividing by a. So the inverse of this function is x minus b all over a. In this next problem, we're asked to delete part of the domain so that the function remains 1 to 1, and then we're supposed to find the inverse and find the domain of the inverse function. So what I've already done is I've graphed this y equals 16 minus x to the fourth, and as you can see, the graph is not 1 to 1 when you're talking about the whole function, but if I chop it off so that I say that it's just when x is greater than or equal to 0, it is now 1 to 1. So the domain we're going to be using is that this is 1 to 1 for x is greater than or equal to 0. So now I'll go ahead and find my inverse function. Again, we'll flip-flop the x and the y and solve for the y. So I've got x minus 16 equals negative y to the fourth. Divide by negative 1. 16 minus x equals y to the fourth. Take the fourth root of it, and I have my inverse. We're also supposed to state the domain for this. So the domain would be x has to be less than or equal to 16. If x is greater than 16, we now have a negative underneath that fourth root. On these next problems, we're supposed to decide whether or not it has an inverse. On this first one, we're talking about tides. And if you think about a tide comes in and it comes out. And so the height of those tides could be the same height at different times along the 24 hours. So this would be not 1 to 1. So this is no inverse because the height of the tide could be the same at multiple times, therefore making it not 1 to 1. The second one says that we have an area of A of R is the area of the circle of the radius R, and so we want to know if this is 1 to 1. So if we start thinking about what's going on, if the radius increases, the area is also always increasing, so there's a specific area for each radius. So the answer to this is yes, because as the radius increases, so does the area. Therefore, the function is always increasing. And has an inverse. Okay, and my last problem that I'm going to do, I'm actually going to do this problem twice, and I'm going to do it in 2 ways. I'm going to do it in 2 ways because there will be times that we cannot do it with this first method I'm going to use. So it says, first of all, verify that f has an inverse. So I will do that. I could graph this and show you. I'm just going to go ahead and find the inverse. So I'm going to flip-flop my x and my y, square both sides, and then I'll add 4 to both sides. So I find my inverse to be x squared plus 4. So then use the function f and the real number to find f inverse prime of a. So f inverse is x squared plus 4. So I could find its derivative by just taking the derivative, and then I'm supposed to find it at 2. So f inverse prime at 2, plug in 2, ends up being 4. Now I'm going to show you another way you can come up with the same answer using a different technique. And this technique you need to learn because they're the types of questions they like to ask on the AP. They want to know if you know this concept. There's also where you have to use the second method rather than the first method. So what we know about inverse functions is that their x and y's are flip-flopped. So I know this is really asking me f inverse prime of x. So this is the x value on the inverse function. So 2 comma something is on the inverse function. Well, what that means is that something comma 2 is on the f function because the x and the y flip-flop spots on inverse functions. So what I want to do is I actually would want to solve this function with y being 2. That'll allow me to be able to find that x value. So I'll square both sides, and then I'll add 4, and I get that x is 8. So I now know that 8 comma 2 is on the f graph. And I now know that 2 comma 8 is on f prime or f inverse prime. So this is actually going to be, I'm going to be able to figure out some things from actually do is I'm going to find the derivative of this, and this method has to be used when you cannot find the inverse very easily. And there's problems where you cannot find the inverse very easily because you've got an x cubed or something along those lines. So what we're going to do is we're going to find the derivative of f instead because this seems much more manageable rather than trying to find the inverse. I know we did find the inverse on this problem, but like I said, there are problems where we can't find the inverse, and the derivative is the easier route to go. So we take this derivative, and we find that the derivative is 1 over 2, the square root of x minus 4. Now, I really want to know what's going on at this particular point because this is the point that we're actually looking for up here. It's 2, 8. But if I can figure out what's going on at 8, 2 on f, I can then figure out what's going on at f inverse. So I'm going to plug in 8. And I'm going to solve. So I get 2 times the square root of 4, which is 2. And I end up with the answer of 1/4. What you need to know about f and f inverse slopes, derivatives, is that they are reciprocals of each other. So I now can make the statement that f inverse prime of 2 is equal to 4 because these are reciprocals of each other. Number 73 in your assignment will be something similar to this, and I will be happy to re-explain this in class as well. Hearing it multiple times will be beneficial.